An international collaboration led by Kobe University researchers has successfully developed a nanosheet laminated photocatalytic membrane that demonstrates both excellent water permeance and photocatalytic activity. The membrane's photocatalytic properties make it easier to clean, as irradiating the membrane with light successfully reduces fouling. They developed this membrane by laminating 2D nanomaterials, nanosheets, onto a porous support. This development was made by a research group at Kobe University's Graduate School of Science, Technology and Innovation, Research Center for Membrane and Film Technology, Associate Professor Nakagawa Keizo, Professor Yoshioka Tomohisa and Professor Matsuyama Hideto, in collaboration with Professor T. The results were first published in the Chemical Engineering Journal, on April 7, 2022. Main points: the researchers successfully developed a novel nanosheet laminated photocatalytic membrane that demonstrates both excellent permeance and photocatalytic activity. The synergy of the nanosheet materials greatly enhanced both water permeability and photocatalytic activity. It has been reported that 2/3 of the world's population will suffer water shortages by 2025. To prevent these severe water shortages, the widespread adoption of water recycling and purification technologies, as well as efficient usage of water production technologies, e.g. seawater desalination, are crucial. The membrane filtration method is currently used in 900 water purification plants because it continuously and stably provides good quality water. However, there is the problem of membrane fouling, where the membrane, which separates and removes contaminants from the water, becomes clogged. When membrane fouling occurs, it is no longer possible to obtain the required amount of treated water. Therefore, it is necessary to either wash or replace the membrane. To tackle this issue, much research has been conducted into various methods of fouling prevention. However, a sufficient solution has yet to be found. One method has been proposed that requires less energy and has a low environmental impact. This involves introducing a photocatalytic material, such as titania, into the membrane and removing pollutants via photocatalysis. However, in addition to being able to treat water, such a membrane must also demonstrate visible light responsiveness and high photocatalytic activity. This requires the designer to consider the membrane's design from multiple perspectives, including the membrane material and structure. They developed this membrane by laminating niobate nanosheets, a type of metallic oxide nanosheet, with each sheet being around a nanometer thick and a couple of 100 nanometers wide, onto a porous support membrane, which created the 2D channels between the nanosheets. In this study, they discovered that adding carbon nitride nanosheets, which has visible light responsiveness, to the niobate nanosheet layered membrane gave the membrane enhanced water permeance while greatly increasing photocatalytic activity. In terms of membrane functionality, the laminated nanofiltration membrane with a 74:25 ratio of niobate, HNB308, nanosheet to carbon nitride, GC3N4, nanosheet maintained its separation performance while demonstrating an 8-fold increase in water permeance. In terms of photocatalytic performance, the integration of carbon nitride nanosheets enabled visible light to be absorbed. In addition, this combination of nanosheets greatly improved the membrane's ability to photodegrade cationic dyes, rhodamine B. Consequently, the channels in the laminated membrane expand, greatly increasing the rate of water permeation. Controlling the channel structure in this way enables 90% of a dye, with molecular weight of approximately 1000, to be separated from the water. Using these results as a basis, The researchers applied the membrane to water purification and conducted a membrane fouling experiment using bovine serum albumin, BSA, as the foulant. Further research by interweaving different types of nanosheets to form 2D nanocanals. The researchers successfully developed a membrane that demonstrates both excellent water permeance and photocatalytic activity. It is expected that further improvements can be made to membrane functionality and photocatalytic action by changing the type of nanosheet to more precisely control the formation of 2D nanocanals and the band structure. Next, the researchers hope to increase the membrane area and develop the photocatalytic process, aiming for industrial and practical application. Studies have reported on various types of nanosheets such as metallic oxide nanosheets, e.g. graphene oxide, carbon nitride, a family of materials. In this study, a planar structure consisting of hydrogen, carbon and nitrogen atoms, graphitic carbon nitride, Gc3N4. It is a semiconductor with a small band gap, and is a visible light-responsive photocatalyst. Chemical Engineering Journal, 2022, 442–136254 doi, 10. 1016, J. CEJ. 2022. 136254 Kobe University. New photocatalytic membrane that can be cleaned using light energy. Revolutionary technology can tackle global water shortages and energy issues. Science Daily. https://ift. tt. AUR v40w. Access July 5, 2022. Thanks for watching. Please subscribe my channel for more videos.